Okay, to show you how to do that then, I'm going to take this short line here. So it's nothing to do with the asymptotes, they're finished with now. I'm going to take this short line here, I'm going to divide that up into 3 parts. Okay, so 1, 2, 3. And I'm going to take the last one, and I'm going to just join it here. And then using sliding set squares, I'm going to continue that line division up. So this one here, and this one here. I'm also going to divide this line up into 3 parts, but it's 60, so I'm just going to use measurements for that. Now, using this vertex, I'm going to join these 2 down to this vertex. And using this vertex, I'm going to join these 2 to this vertex. That finds for me 2 points on the hyperbola. And I can draw in the hyperbola. I can then mirror that hyperbola down into plan. So I'm just going to bring lines down. You could also repeat the process if you want to, but I find it faster to mirror it. So from here to that point there, out to the side, from here to that point there, or sorry, from the middle to that point there, out to the side. And that gets me the next part of it. And I'll mirror it all out this way. And you don't have to use the same dots again. You can use any dots you like. You know, you can make up your own points. You can even get extra points if you want, just to be more accurate. And I'm mirroring that across this way. And the same down on plan. And that finds my hyperbola now in plan. Now I know it's rounded off at both ends in the question. That's a little bit unfair really, because that's got to do with the 60-degree angles in front elevation. So we'll end up having to do an immense amount of horizontal cuts onto this in a minute. So for a question that was actually only a part A of a question, it is quite long. It would actually be good enough to be a question on its own. Now we're going to get the front elevation next. Now, you're told it's a hyperbola of revolution. So that means this curve has been revolved around this line to make this circle that's down here. So that means in front elevation then, essentially, what we're looking at here, this shape here, is the front elevation without the 60-degree lines. So I'm just going to use tracing paper to move this exact thing up to here. So I'm going to color it in just to show it to you. I'm going to move this object here from plan up into front elevation. Okay, so just using the tracing paper. Now the tracing paper won't show up on the camera, but I promise you that's how it's done. You can do it a different way if you want to. It doesn't have to be done with tracing paper. So I'm just marking out the corners. Now, leave inserts and fixtures for your exam. If a question comes up where you use tracing paper of any description, you have to make sure that you submit it with your examination number on it, so that it can be used in the exam and tested. So I'm just tracing that. I'll put that now up in front elevation. Oh, I need to get the middle of the object. Middle dot. That then ends up here. And what I'm going to do with the tracing paper is usually I shade it in, but today I'm just going to punch through. And then I'm going to join the punch dots on the other side to speed things up. Okay, so that gets the front elevation. Now the thing I did there with the compass, punching through, of course you can do that. You can do that yourself, there's no problem at all. Now, so that finds the front elevation of the object. You're then told that there are two ends at 60 degrees, which is what I'm going to get now. Here is one of the 60 degree lines. And here is the other 60 degree line. Okay. Now, so that is the front elevation and plan drawn. What's next to do now will be a curve around here and a curve around here, which we're going to talk about in the next video.